This video is for section 8.2, number 10. 3 solid uniform boxes are aligned in the figure below. Find the x and y coordinates of the center of mass of the 3 boxes, measured from the left corner of a box A. Consider the 3-block system. Okay. So we need to find the center of mass, both the x and y coordinates. We can do the x coordinates first. The center of a mass equation is as follows. So we have 3 masses A, B, and C, and those will be respectively 1, 2, and 3. The mass of each block is given in kilograms, and we need the center of mass for each block. So the location of the center of mass we want to take with respect to the origin. So if our box is uniform, the center of mass would be in the center of that box with respect to the origin. So the center of mass for box 1 would be halfway of the 0.25 meters. (0.25 divided by 2). 0.125 meters is the location of the on the x-coordinate of the center of mass of block 1. For block 2, we need the center of mass, but with respect, again, to the origin. So the center of mass would be about this x-coordinate right here. So that would be 0.25 meters away plus 0.35 meters divided by 2. The center of mass for the x-coordinate of block 2 is at 0.425 meters. We do the same for block 3. So this time we have the 0.25 meters plus the 0.35 meters, and then we're halfway of the 0.15 meters. (0.675 meters), and these will be the x-coordinates we use in our equation. So we can go back to the center of mass equation for the x-coordinate. And we have mass 1, 0.75 kilograms times the center of mass for mass 1 is 0.125 meters. We do the same for mass 2 and mass 3. and then that is divided by the sum of the masses. And then we'll see what we get. So the x-coordinate of the center of mass is 0.374 meters. And that was part A of the question, which I'm now going to erase so we have room for part B. And that will be looking for the y-coordinate of the center of mass. So our equation is very similar, but now we use y instead of x. Divided by the sum of the masses, which is m1 plus m2 plus m3. So it looks the same as the x equation, but now we're using the y coordinates. And each box, so they're uniform boxes, each with a height of 0.35 meters. So the center of mass will be located at half of that 0.35 meters. And this will be the same for 1, 2, and 3, which are A, B, and C, because they all have the same height. So the center of mass, the y-coordinate of the center of mass for box 1, 0.35 meters divided by 2. Which is equal to 0.175 meters. And that is the same for boxes B and C, or 2 and 3. We are now ready to go back into our center of mass equation for the y-coordinate to find our final answer. So mass 1, 0.75 kilograms, times the y-coordinate of the center of mass for mass 1, 0.175 meters, and then the same for mass 2 and mass 3. And this all divided by the sum of the masses. And the y-coordinate of the center of mass is, as you may have expected, 0.175 meters.